Now the next question is, an electric dipole consists of two charges of 1 millicoulomb and minus 1 millicoulomb. They are separated by a distance of 4 into 10 to the power minus 2 meter, right? They are separated by that distance. If the axis of the dipole makes an angle of 60 degree with the direction of uniform electric field of 10 to the power 5 Newton per coulomb, find out the torque, right? So at first make the diagram and understand the concept what the question is asking for, right? So it is, we have to find out the torque on an electric dipole, right? So suppose we are just assuming that this is our uniform electric field, okay, and this is our uniform electric field, and this is the direction that I am just drawing over here. And if the dipole is like that, if the dipole is like that, and this is the point A, this is the point B, and it is creating some angle of 60 degree, creating some angle of 60 degree with that of direction of electric field, right? And we have to find out the torque experienced by the dipole. So at A point it is having a charge of plus 1 millicoulomb, and at B point it is having a charge of minus 1 millicoulomb. Sorry, coulomb. The electric field is having the strength of, electric field having the strength of 10 to the power 5 Newton per coulomb, right? So what's the formula to find out the torque? So why the dipole is experiencing that amount of torque? Because when the dipole is placed in an electric field, the electric field will apply some force on both of the charges, right? So the expression for force, that is equals to Q multiplied by E. That amount of force will be applied on both of the charges, and due to that it will rotate in some direction. That's why we have to just find out the value of the torque. So the expression for torque, that is equals to PE sine theta. Expression for torque, that is equals to P sine theta. So we have to find out the magnitude of P, that is equals to the dipole moment. So what is the dipole moment over here? If we calculate the dipole moment, that is equals to the charge, that is 1 millicoulomb, that is 1 into 10 to the power of minus 3, multiplied by the separation distance. What's the separation distance between them? That is of 4 into 10 to the power of minus 2 meter, right? So you have to just put the value over here, and the answer will be 4 into 10 to the power of minus 5, right? Now if I just put all of the values in that formula, that torque equals to P sine theta, what the answer I will get? That is equals to the dipole moment, that is 4 into 10 to the power of minus of 5, multiplied by the electric field, that is of 10 to the power plus 5, and sine theta, that means sine 60. What's the value of sine 60? That is equals to root 3 by 2, right? Now that will be, if I just proceed with that of calculation, then 10 to the power 5 and 10 to the power minus 5 will be eliminated, and it will be 4 sine 60. 4 sine 60 means 4 root 3 divided by of 2, right? That Newton meter, right? So this is the final answer.